All right. Hello, everyone, and welcome to the book launch for Consumer Genetic Technologies, Ethical and Legal Considerations. This is a book that came out of the Petrie-Flom 2019 annual conference, which brought together leading experts to explore what ethical and regulatory safeguards should be implemented around the use of consumer genetics, mostly focused on testing, but with a discussion of biohacking as well as genetic editing. I think this is such an interesting topic. I will say that the subject of the conference and the book was actually inspired by my own personal experience with 23andMe, as well as its interaction with the healthcare system when it revealed a predilection towards breast cancer running in my family for my mother and myself. I won't take up too much time before we get to our fantastic panel, but before that, a little bit of housekeeping, the digital equivalent of where the bathroom is. We are hoping for a lively Q&A. You might ask, how can I, as an audience member, submit questions? There are two good ways to do it. The best way is to use the Zoom Q&A feature found in the meeting controls at the bottom of your screen. If you click on that box and submit a question, our moderator will be standing by, reviewing the questions and pose them to the panelists. If you would like to join the conversation or submit your questions through an alternate route, please go onto Twitter and use the hashtag consumer genetics. Again, that's hashtag consumer genetics, and add us at Petrie-Flom. If you have any technical issues, please email us at petrie-flom@law.harvard.edu. If you are interested in our further events, please sign up for our newsletter. Please go and read Bill of Health, which is our blog that covers health policy, health law issues. It's very, very topical. And then check out some of our forthcoming events. I will also say that the Zoom raise your hand feature, that little hand is very cute, but we are not going to monitor that. So really the best way is to contact us either through email if you have a technological issue, or Q&A if you have a substantive question for our panelists. Speaking of panelists, who is going to be speaking today? We have a really all-star lineup of fantastic scholars and really just rock star human beings. The first up is going to be Emily Largent, Assistant Professor, Medical Ethics and Health Policy at the Perelman School of Medicine at University of Pennsylvania. She's going to be followed by Natalie Ram, Professor of Law at University of Maryland Francis King Carey School of Law. Jake Scherko is going to round out our panelists. He's Professor of Law, College of Law, and affiliate Carl R. Wasey Institute for Genomic Biology at the University of Illinois. And our distinguished moderator is going to be Henry T. Greely, Dean F. and Kate Edelman Johnson, Professor of Law, Professor by Courtesy Genetics, Chair, Steering Committee of the Center for Biomedical Ethics, and Director at the Stanford Program in Neuroscience and Society at Stanford Law School. With that, we're going to dive right in. I would like to hand it over to Emily as our first presenter.
Great, thank you so much. I'm really delighted to be here today, and congratulations on the book launch. So when I wrote the chapter for this book, I focused on the ApoE gene, which is a gene that talks about risk for late onset Alzheimer's disease, or Alzheimer's disease where the onset date is after your 65th birthday. So I looked at this particular gene because it turns out this is a very controversial test to be offered in the direct-to-consumer context. And in the medical school and the circles where I run, it's not usual to hear people talk about 23andMe with sort of hushed and ominous tones when they think about the consequences potentially of direct-to-consumer ApoE testing. So my motivation in thinking through the chapter was really that if we can understand and address some of the concerns that arise in the context of ApoE testing specifically, given how controversial it is, that we can find ourselves reassured and drawing lessons about genetic testing, direct-to-consumer genetic testing more broadly. So my goal for the next few minutes is to offer some highlights from the chapter and also to discuss a few updates, things that I would be working in if I were to be writing the chapter now. So by way of brief background, there are multiple known risk factors for Alzheimer's disease. So these include your age, race, sex, your personal medical history, your family medical history, and also, of course, genetics. Now, researchers have not found a single gene that will tell you whether or not you will certainly get late onset Alzheimer's disease, but there is a susceptibility gene, ApoE, which is well known. There are 3 variants or alleles of the ApoE gene, and these dictate how much risk you carry. So the E2 allele is relatively rare. It provides some protection apparently to individuals. The E3 is the most common, believed to play a somewhat neutral role in risk. And then the E4 allele increases risk and is associated with an earlier age of onset. Now, it's really important to stress that having an E4 allele is neither necessary nor sufficient to develop Alzheimer's disease. Not all people who have an E4 allele will develop Alzheimer's disease, and roughly half of those who develop Alzheimer's disease have no E4 alleles at all. So right now, when we look at the clinical context, right, so not direct to consumer, but looking at the clinical context, ApoE testing is generally not covered by insurers and it's generally not offered clinically. And this is because, there are a host of reasons people offer, but to highlight a few, one, ApoE is not needed for a diagnosis of Alzheimer's disease. Having that E4 allele doesn't rule out or rule in that a patient has Alzheimer's disease as the cause of their dementia. It doesn't change prevention strategies or treatment strategies to know that somebody carries an E4 allele. Some people also worry that it's just very difficult to communicate ApoE risk because it's very probabilistic and they think people won't understand the results. And there are also some concerns that it's not safe to disclose this information given how feared dementia is, right, which is the effects on your memory and thinking, and Alzheimer's disease being the most common cause of dementia. The thought is that this is the kind of information that can be unsafe to give to people. So we can say all of those reasons why I think somewhat paternalistically people want to interfere and say they're not going to disclose ApoE results clinically. But the fact of the matter is that people do want this information. So I'm going to tell a true story. This is not a true picture of this story, but a true story of direct-to-consumer genetic testing. So one of my very oldest friends, and by that I mean somebody I went to high school with, not numerically old, ended up doing 23andMe genetic testing just for fun. And she was clicking through her results to see what she could learn about her earwax and whether or not cilantro tastes like soap, when she saw that she had 2 variants detected for the ApoE gene. Now, 23andMe only speaks to your E4 alleles, so this meant that she was an E4 homozygote. She wasn't really quite sure after reading this report what that meant or even what she should think about it, and so she took a screenshot of her 23andMe report and she texted it to me along with these questions. Well, should I be worried? And if I'm worried, what should I do? So as somebody who spends a lot of time thinking about this, I kind of had to sit back for a minute and think, oh boy, what am I going to tell her to help contextualize these results? So it turns out that I spend a lot of time talking with people who have learned their risk for Alzheimer's disease, either through genes or biomarker testing. And these are people who have chosen to participate in Alzheimer's disease research. So what we know is that this is a diagnostic label with particular significance. People consistently point to 4 differences between ApoE test results and other kinds of medical information they might receive. So the first of these is they highlight the ways that memory and thinking play a uniquely important role in identity formation and their sense of self. So people talk about how this result, unlike say a colonoscopy, because their brain is involved, has a different import. They also report that having this information changes how they think about their own memory. So E4 carriers are more likely to reinterpret memory concerns as perhaps the onset of Alzheimer's disease, whereas other individuals are likely to think, who learn that they don't have an E4, are likely to think of this as normal aging. People express concern that others will treat them differently in light of this information. So that's stigma or negative attitudes, and discrimination, which is behaviors based on those attitudes. And that can occur in the workplace, in insurance purchasing, or in housing purchasing. People talk a lot about the uncertainty of outcome. They're really not sure if they're ever going to develop dementia caused by Alzheimer's disease. And finally, they speak about the lack of medical actionability. There's really not a lot they can do to step in and prevent the onset of dementia. Now, I will say this is one of the two main updates I would offer since I wrote the chapter, is that FDA recently in June of 2021 approved Aduhelm using the accelerated approval pathway for the treatment of Alzheimer's disease. It was incredibly controversial given that there is uncertain evidence of benefit, but there is very clear risk and very high costs associated with it. So as of now, there hasn't been particularly strong uptake of Aduhelm in the marketplace, but really FDA did open the door for other companies to put forward drugs for Alzheimer's disease. So this last category, I would say, is in the midst of changing. Now, we also know that learning your Alzheimer's disease risk or APOE result is generally safe. So I have to offer the caveat that this is from relatively homogeneous populations, but we don't see depression, anxiety, or suicidality after people learn their risk. Now, that being said, we don't want to sort of overshadow that there's a really rich emotional reaction once people learn these results. Unsurprisingly, people who learn they're not carriers often talk about relief and happiness to the point of ecstatic joy. And people who learn that they're at increased risk can talk about sadness, disappointment, worry about burdening others. They talk about, fear that they're going to become a shell of a person. Nevertheless, once people learn whether or not they carry an APOE E4 allele, they often talk about this information as being empowering. And we see this in two main areas. The first is that individuals often adjust their health behaviors. So people who learn that they have an E4 allele will start running again. They'll take on the Mediterranean diet. They talk a lot about playing Sudoku, engaging socially, volunteering more to try to keep their brains active. The other thing to do is they alter their future plans in light of this information. So individuals who learn that they don't carry an E4 allele talk about having a more open or broad sense of their future, feeling like they're freer to plan ahead. But people who carry the E4 allele will contemplate changes or actually make changes to wills, advance directives. They might downsize a house, move closer to an adult child, typically a daughter who can serve as a caregiver. They will also make trade-offs between working longer to save money for caregiving or retiring sooner to check things off the bucket list before they're no longer cognitively able to do that. So the second big update since the chapter came out is that I don't think that APOE genetic testing is the only kind of direct-to-consumer testing for Alzheimer's disease that we're going to have. There's a lot of enthusiasm in the scientific community for blood tests for Alzheimer's disease biomarkers, and those biomarkers speak to the presence of AD pathology. So you can actually start to see changes in the brain that are indicative of Alzheimer's disease. And there's a feeling that within the next few years, we should have tests that can consistently do this using just a blood sample. So if that happens, I would say that we are going to have direct-to-consumer biomarker testing. And that's because both we have already a regulatory framework for FDA to look at tests like these, and there's a business model. We know that there are already multiple companies that exist where people can bypass that traditional clinical encounter to have blood tests ordered and go ahead and order it themselves online. So with that, I think we're going to see that APOE testing is not actually the end of it. It's actually the first of many direct-to-consumer tests that we're going to have for APOE results. So in wrapping up, I would just say that there are a lot of reasons why people are worried about APOE testing, but the evidence really doesn't bear out that those are as worrisome as people think they are. That said, I think that services like 23andMe are not doing people like my friend any services by simply telling them they have E4 alleles. It's really important to contextualize this information, to talk about the uncertainty of risk, and to help understand what other people do in light of this information. So I'm not suggesting that 23andMe should offer any sort of prescriptions for what people do, but as they already link to scientific evidence, they should think about linking to social evidence about how people use these results. So the bottom line is that nobody should be in the position of needing to text a friend to say, now what? Thanks.
Hi, so I'm your next speaker, and I just want to thank everyone for being here and for inviting me to speak with you today. I'm going to speak a little bit about law enforcement use of consumer genetic technology and its growth and some problems with that use. So since the April 2018 arrest of the Golden State Killer, law enforcement investigators have made arrests in scores of cold cases. Investigators in these cases compare preserved crime scene DNA to other DNA profiles in online genealogy databases. In nearly all of these cases, those searches in turn uncover partial genetic matches to known but distant genetic relatives of a putative suspect. And through sleuthing in the resulting family tree, investigators have been able to identify suspects for investigation and in some instances, arrest. Now, law enforcement interest in using consumer genetics platforms to solve more crimes has unsurprisingly materialized rapidly and continues to grow. Parabon Nanolabs, which was the first private company to capitalize on law enforcement interest in this technique, investigative genetic genealogy, now has several competitors in the field. And at least 2 consumer genetics platforms, GEDmatch and Family Tree DNA, openly cooperate with law enforcement efforts. The field is also already maturing. GEDmatch started out as a hobbyist genealogy site, but it has since been acquired by a forensics company, Veragen, thus formally shedding its hobbyist roots for a forensic future. Now, proponents of using these consumer genetic platforms to investigate and solve crimes have argued that the genetic data on which these investigations rely has been voluntarily uploaded and shared. Individuals at Parabon Nanolabs and elsewhere have emphasized that investigative use of these platforms utilizes only voluntary data, while sites that cooperate with law enforcement have likewise emphasized supposed voluntariness by, say, introducing new options that permit site users to opt out, at least in theory, from most law enforcement uses. But I want to suggest that this assertion of voluntariness is mistaken on both intrinsic and practical grounds. And the reason for this is as follows. In nearly every case thus far announced, the individual who was ultimately arrested did not himself upload his identifiable genetic data to a consumer genetics platform. Rather, that individual was identified through a match between crime scene DNA and the profile of a genetic relative. In many instances, including in the case of the Golden State Killer, the genetic relative whose DNA and identity was available to police was a distant one. And yet, identifiable genetic data is shared within families in profoundly involuntary ways. After all, as we all well know, we don't choose the families into which we are born. Now, parents might in some sense be said to volunteer to share their genetic data with another person by choosing to procreate. But children, poor children, cannot be said to have chosen their genetic parents, nor do individuals in any real sense choose how many siblings their parents give them, or whether they have aunts, uncles, cousins, how many, and what arrangement of each. Rather, these genetic similarities arise as a product of biology, without voluntary conduct or choice. These genetic ties are also immutable, not merely involuntary, but immutable. The identifying DNA that an individual inherits from her parents is the identifying DNA that she'll have all her life. Unlike a stolen credit card, one's genetic sequence cannot be changed. And these features of intrinsic involuntariness and immutability render genetic relatedness unlike most other relationships of data sharing in which individuals find themselves. Genetic relatedness is stickier even than the social relationships we have with our family members. For instance, I could decline, say, my aunt's friend request, for instance, or I could unfriend her or disassociate myself from her on social media. I could even go further and estrange myself from her in the real world, thus largely depriving her of information about, say, my new car, my comings and goings, my significant other, and the like. And yet, that aunt could still serve as reliable as ever, a genetic informant, because our tie is involuntary and immutable. Assertions of voluntariness are also misplaced in the context of genetic relatedness on practical grounds. Consumer genetics platforms like 23andMe, Family Tree DNA, and others typically use wide-ranging genetic sequence data drawn from hundreds of thousands of DNA data points. Parabon Nanolabs again advertises that it can detect relatedness out to 9th degree relatives. That's your 4th cousin, while determining the precise degree of relationship out to your 6th degree relatives. That's your for instance, second cousin once removed. How many of us are even certain we know who all of those cousins are? Under these circumstances, it is simply unmanageable for an individual to know of, monitor, and persuade each of those relatives to protect her genetic privacy if that's what she desires. Now, I argue that this disjunction between claims of voluntariness and the reality of familial forensic identification is problematic for both logical and legal reasons. So for one thing, if the rule supplied by law enforcement for its use of consumer genetic data is voluntariness, the data is voluntarily provided, and if implicitly included genetic relatives are included involuntarily because of an involuntary genetic association, they just don't fit the rule for inclusion. And their inclusion in law enforcement efforts is therefore inappropriate. For another, the result of familial inclusion in investigative genetic genealogy for law enforcement use amounts to a de facto national DNA database, or something rapidly approaching one. More than 26 million people have already made use of some consumer genetic service, and these platforms continue to grow, although at a slower rate than previously seen. Law enforcement access, though, to as little as 2% of the population, perhaps as few as 5 million consumer genetic profiles, could make more than 90% of Americans, at least those of European descent, identifiable through a third cousin or closer, a relationship that a company like Parabon says they can identify with precision. As law enforcement already has the cooperation of at least 2 consumer genetics platforms, that 2% figure is rapidly coming to fruition if it's not already upon us. A de facto national DNA database is thus on the horizon, if not already here. And yet, no US jurisdiction has indicated that a comprehensive DNA database of residents would be appropriate. Each and every state and the federal government has legislation that identifies whose DNA is subject to routine government search for crime detection purposes. None of them have said that everyone should be in the database. Each instead has limited the database to some subset of individuals arrested or convicted of crimes. Indeed, when legislators have proposed expansions in the state official DNA database to include those without known criminal histories, they have been met with outcry and failure. In other words, many Americans are profoundly not on board with comprehensive genetic identifiability for law enforcement purposes. And in my view, if an authorized comprehensive DNA database would be inappropriate as a matter of policy, the de facto accomplishment of the same end by involuntary genetic associations should be similarly inappropriate. Finally, I think law enforcement use of this kind of data may raise Fourth Amendment problems. The US Supreme Court has interpreted the Fourth Amendment of the US Constitution to protect individuals against unreasonable government intrusions upon an expectation of privacy that society is prepared to recognize as reasonable. In applying this test, the Supreme Court has typically excluded from its concern information that an individual knowingly or voluntarily shares with a third party. But the US Supreme Court has recently begun to chip away at that rule, at least as it applies to sensitive digital data. In its decision in Carpenter versus United States, the Supreme Court recognized that individuals can maintain a reasonable expectation of privacy in their location data, at least as it's revealed by cell site location information, concluding that, among other things, the sharing of that kind of data, that sensitive personal data with one's cell phone provider, isn't really knowing or voluntary, given the ubiquity and necessity of a modern cell phone. Now, it might seem odd to talk about cell phone data and genetics in the same conversation, but I think there are similarities here. Assumptions of either knowing or voluntary sharing of data are similarly inappropriate as applied to familial forensic information. As I've explained, it's a practical impossibility for an individual to know of or monitor each of the hundreds of other individuals whose genetic data may illuminate her own. Nor is identifiable genetic data in any sense a voluntary exposure as between shared genetic relatives, since that data is shared among genetic relatives involuntarily nearly all the time and always immutably. And in the absence of either knowing or voluntary sharing of this data, the Supreme Court has instead held that law enforcement access to this kind of private sensitive data may in fact violate the Fourth Amendment. I think that conclusion is warranted here too. Now, in the book, I offer a possible path forward, drawing on doctrines from property law as an analog for thinking about enmeshed interests in an indivisible form of ownership. In the interest of time, I'm not going to discuss that in detail here, but let me close by simply saying this. Yes, resolving cold cases and bringing wrongdoers to justice is laudable, but investigative genetic genealogy's reliance on matches between involuntarily identifiable genetic relatives should prompt us to ask serious questions about whose genetic data is now included in law enforcement searches and what's the justification for that inclusion. As I've suggested, assertions of voluntariness just won't do. Thank you.
Well, hi everyone. I'm your last speaker today. I'm Jake Scherko. I'm professor of law here at University of Illinois College of Law. And I just want to take just a brief moment just to thank everyone at Petrie-Flom for having me again, all the organizers and of course administrators for the conference, and to Glenn and Carmel for putting the book itself together, which you should go on Petrie-Flom's website to purchase, and to Hank for moderating. The chapter I'm going to talk about, chapter 12 of this book, is a joint work by myself and professors Christy Greely at Baylor College of Medicine and Patty Zettler at The Ohio State University, who really deserve all of the credit and only I the blame. In this world of research, National Institutes of Health Policies, the Common Rule, IRBs, IACUCs, it's surprising that there is genetic biohacking out there, essentially research outside of this institutional ambit for which many of us are used to genetic research being conducted. But it exists and it is growing. There are some estimates that it encompasses tens of thousands of people in the United States. A 2017 report indicated that at least there were 30,000 people conducting it. And I imagine that during the pandemic, when you can get anything that you want on the internet, and you've got, or at least some people do, have a lot of time on their hands, I would imagine that number has only gone up. Is this activity regulated, either de facto or de jure? And should it be? We explore in our piece in this chapter here in 3 parts the answers to some of those questions. We do it by looking first at public regulation, then by also looking at private regulation, and then some of the normative aspects, that is the should questions, in our moving forward section of our chapter. Obviously, it's important that I start off with some definitions, right? What is genetic biohacking? We define it as biological research conducted outside of institutional settings by individuals who may or may not have any formal scientific training. Garage shop hobbyists who have a latent life appreciation for biology can do this as much as PhDs who have founded community resource labs. It is all genetic biohacking for our purposes, and regulating it is a matter of finding a balance between the scientific endeavor, broadly speaking, and of course, safety, health, and welfare, not just of biohackers, but of everyone around. Let's begin with public regulation. So one way biohacking seems to be regulated is through public regulation, the regulation of entities by the government or by public agencies. The most obvious source of these seems to be the FDA, the Food and Drug Administration, right? FDA famously regulates a quarter of every dollar spent in the United States, although these days it's really closer to 22 cents, but still. And notably, the agency has authority over quote unquote drugs. Drugs, as you may know, are those articles intended for, quote, the diagnosis, cure, mitigation, treatment, or prevention of disease, or, quote, intended to affect the structure or function of the human body. This is an objective standard, the intent standard, and it really is broad and encompasses both traditional drugs that we would consider like pills and things of that nature, as well as things like fecal microbiota transplants, of which I will discuss more later. In addition, beyond these, FDA's authority is broad. It has already commented that in 2017, genome editing itself, whether it's by biohackers or otherwise, can be gene therapy under its purview and therefore regulable, leading to a suggestion that some of the biohacking kits that are sold today, at least for humans, are already drugs under FDA law. At the same time, FDA authority generally does not extend to true instances of self-experimentation, at least where no physical article has crossed interstate boundaries or where pure information, rather than an article itself, is the thing that is being trafficked. Some biohacking examples show this. So one case is the EpiPencil by Four Thieves Vinegar Collective, a biohacking collective among many other things, which is just simply a series of instructions on the internet for making one's own knockoff EpiPen for those who otherwise don't want to shell out $600 for a 2-pack. Those instructions alone are doubtfully under FDA's purview. On the genomic side of things, biohacking kits that focus on non-therapeutic uses, such as just playing around with bacteria for fun, probably don't count either. Importantly, as we note in our chapter, drawing this line, though, is really not ever so clear. In the FMT example, fecal microbiota transfer, regulating poop as a drug is something that probably only a lawyer could love, and an FDA lawyer at that. And biohackers rightfully complain of this confusion. This is a shame, we think, because FDA has the expertise here to provide information on safety, as well as public service, and making clear about what the agency does. Even after COVID-19, the public seems largely confused about FDA's role and its jurisdictional authority. So for FDA, it needs to be more clear when it comes to biohacking about the limits of its authority in the experimental space, and relatedly to do more public service announcements to make that clear. To be frank, this is work FDA already does in a variety of other contexts. It's November 2nd. In 3 weeks, we're going to get a lot of messaging from FDA about making absolutely sure our Thanksgiving turkeys are cooked to an internal temperature of no less than 165 degrees Fahrenheit. Why not do something similar for biohacking? Well, that's public regulation. Let's move on to private regulation. Well, to begin with, we have a number of options for private regulation, and one of those options is, believe it or not, patents. Patent holders can police safe and ethical uses of genomic technologies by biohackers by suing rogue users for patent infringement. You're skeptical. Fine, that's fair. But this is an idea that has been floated by scientists in the field and is actually part of genome editing patent license restrictions from several academic institutions. As a historical matter, IP holders have in fact sued downstream users for IP infringement before it occurred behavior, from copyright infringement for illegally downloading music and movies to patent cases against users of not manufacturers, but users of certain infringing photocopying machines. Patents are one tool among several for policing unethical uses or dangerous uses of genetic biohacking. More on point, perhaps, is tort law, and the flip side of that coin, tort avoidance. Biohackers are aware of this. They don't want to get sued if something goes wrong with their kits or in their community labs. And this was identified in structured interviews with biohackers as conducted by Professor Greely. One person said, quote, "If something goes wrong, it's your fault. It's all your fault." Tort avoidance here seems to do a lot of work. It encourages people to shovel their driveways and to carry car insurance. It governs private behavior in myriad ways and can do so for the biohacking community here. There are also community mechanisms in place, essentially safety policies and even agreements, contractual agreements, concerning compliance using the biohacking space. You want access to a community lab? You got to play by the rules. This is a form of self-policing that works as well as any formal mechanism may otherwise do. All right, moving forward. So genetic biohacking is out there. It's used in drug manufacturing, genome editing, DIY medical devices. The interest is there. What to do about it? Well, first, whatever policies we impose on genetic biohacking, we can't expect 100% compliance. There are going to be rogues. This is true even in institutional contexts with all of its safeguards. There's He Jiankui, of course, but there's also instances of professors that you've never heard of in institutional settings engaging in more day-to-day research misconduct. Our policies there are not a failure because some people break them, any more than criminal law is a failure because we continue to have criminals. Indeed, one may argue the law is a victim of its own success. Beyond this, regulators need to better engage with the biohacking community. Engagement does not mean giving a free pass to. It means making clear which conduct is going to be enforced and then actually doing the enforcement, and then educating the rest so that people can do it safely. Other regulators have done this at workshops before, and we should continue. To be sure, this is not going to be universally appreciated by genetic biohackers. Among some biohackers, not all, there's a decidedly anti-government sentiment. Government, get out of my community resource lab. Engagement may be a bulwark against this, at least one might hope if we are wild optimists. Third, we, and by we, I mean the institutional people in this room, recognize benefits of community science. That is, we must do so. We already do this for open innovation initiatives. Some of those are sponsored by public agencies like Department of Health and Human Services and FDA's competitions regarding health apps. Biohackers tend to be users of these technologies. They are aware of their pitfalls, and we should not waste their understanding of the way that these technologies are used as a resource. Fourth, it's probably pretty important that we tailor enforcement to the particular approach employed. Experimenting on yeast to brew in beer, well, that's one thing. But developing, say, an insufflated protein-based COVID-19 vaccine for wide distribution to the public, that's another, and should be policed differently because of the potential for harms. As our chapter's title suggests, it's simply all about finding this right balance. All right, thank you very much. I'll turn it over to you, Hank.
Well, thank you, Jake, and Emily, and Natalie. I am Hank Greely. I am moderator for this, which means I'm going to be reading the questions that you put into the Q&A box. So please put questions into the Q&A box and transmitting them to our speakers for their takes on them. Before I do that, let me just say a little bit about the background of this. This was a great conference that was held in May of 2019, approximately 8 months BC. It wasn't actually the last conference I went to before COVID, but it's sort of the last memorable one I went to before COVID. And it was a lot of fun. However, it was in theory organized by Glenn Cohen, Nita Farahany from Duke, and myself, but in reality, it was organized by Carmel and the other Petrie-Flom staff. And we had 20-some speakers. 20 of those presentations have turned into chapters for this book. So the book is a direct result of that excellent conference. The only minor complaint I've got is the book, apparently at the insistence of Cambridge University Press, is entitled Consumer Genetic Technologies, but the conference was called Consuming Genetics. And I thought Consuming Genetics was a much better name, but that may just be because I like consuming things. However, still a good book, still a lot of interesting sections, chapters, and a lot of interesting questions we can have from the audience. So please send your questions to the Q&A function on your Zoom. Let's start though with one that we've gotten, and this I'm going to aim at Emily. How much better over the last 20 years, if at all, have we gotten at understanding what the risks are of the various ApoE statuses, 4-4, 3-4, 2-2, et cetera?
So when we talk about these numbers with patients and research participants, even now, we tend to give these very wide ranges. So for an E4 homozygote, we say that the risk of developing mild cognitive impairment or dementia caused by Alzheimer's disease is in the range of 30 to 55%. And 1 in 3 sounds a lot better to me than 1 in 2. I would say that part of the challenge here is that we have so many factors involved in whether or not someone develops mild cognitive impairment or dementia caused by Alzheimer's disease. I listed out, age, race, sex, personal medical history. I think it's hard to give that kind of precision. There are some researchers who are trying to create personalized calculators that I think will do a better job, with ApoE being one factor of many. The other area that we continue to need to improve here is just having more representative populations. I think we understand how the E4 allele works, very well in some populations, but not in others. So progress is slow. I think that ApoE should be part of a multifactorial consideration of risk.
Okay, well, here's a question for Natalie. Two of the, GEDmatch and Family Tree DNA are cooperating to some extent with law enforcement. I think GEDmatch initially went to an opt-in, and then it went to an opt-out, and back and forth. But the two biggies, Ancestry is far and away the largest, and 23andMe is kind of half its size, or 60% of its size, are not. Has this caused a slowing in the use of genetic genealogy in forensics? I haven't seen as many newspaper stories about it, but that may just be because it's old news. Any sense of the trend?
The trend in the growth of these services, or a trend in the growth of cases resolved using these techniques?
The trend in the attempts to resolve cases, which you could probably only get from the numbers of cases resolved.
Yeah. Okay. So I still get plenty of alerts indicating that there's work continuing in this space. I think when this technique first made headlines, there were a lot of cold cases that had perhaps more easily usable DNA, and so there were headlines of an arrest almost every week. I will say since the beginning of the pandemic, the headlines have slowed down. Now, whether that indicates a slowing in law enforcement use or interest, or whether that reflects the media's attention on another science-y topic, I might think it's a little bit of both. I do know that the federal government is making funds available to local law enforcement to try and clear cold cases using this technique. When that happens, there is an interim policy in place from the Department of Justice that governs how those investigative genetic genealogical searches are conducted. But I think the DOJ policy, in my view, doesn't go far enough. In a number of key aspects.
If I can follow on that for a second, it doesn't have to be a genetic genealogy database to do this. You just need a really big, broad genetic database of some sort. Obviously, the CODIS database is one, and its use for genetic genealogy is quite limited, as I understand it.
Yes.
But we've got these increasingly large research databases, and ultimately, we're going to have genetic information in electronic medical records. It won't be in the form of the CODIS markers, but it will be in SNPs that can equally be used. Have you seen anything yet about the use of non-corporate genetic genealogy databases for this kind of forensic use?
So I'm so glad you asked, because that is what I'm thinking about and writing about and researching now. I've been thinking and looking at consumer genetics data for the last while, and my attention has now been shifting towards precisely those research and clinical data. Now, my primary interest here, and I think kind of the lowest hanging fruit, is newborn genetic data. Nearly every infant born in America has a blood sample taken within 24 hours of their birth, and that is sent to a state lab for analysis. It's not usually, or it's not largely, genetic sequencing, but if you talk to the folks at the federal government, at NIH and NHGRI, they say it is only a matter of time before we are doing genome sequencing. I think there's opinions that vary on how soon or likely that is to come to pass, but if and when it does, that will yield genetic sequence data for virtually every American. And at that point, my focus has turned to what are the state policies in place to protect that extraordinarily valuable resource, both from a clinical perspective, because it's, newborn screening is designed to ensure the health of every newborn American in certain ways, but it's also an extraordinarily valuable research repository. And if we want to protect that for both clinical and research uses, we might want to rule out indiscriminate law enforcement use, which might undermine public trust in those programs entirely.
My recollection is from some litigation in Texas and in Minnesota.
And ongoing in Michigan now.
Yeah, and the issues seem to be completely state by state, and there's a lot of variation about what gets preserved and saved and what doesn't.
That is absolutely right. And for how long?
Yeah. So Jake, I liked your example of poop as a drug. I think I've had dogs before who thought that was the case, as far as I could tell, but maybe they just thought it was food, refried dog food. But I've got another example. The FDA views cloned human embryos as drugs, possibly as biological products, probably as both, but certainly as jurisdictionally within its power. If you were the Tsar and able to do anything you wanted with FDA and DIY, what's the most important thing you would do?
I mean, I think there's two main concerns, one of which I've written about actually with the same suite of co-authors plus one more, and another one of which I think it's just kind of garden variety FDA stuff. So the one I've written about with other co-authors, this again is me, Christy Greeny, Patty Zettler, and in this case, Michelle Meyer at Geisinger Health, is in the DIY bio space, the availability of the stuff, or at least the promulgation of it as being safe and effective, even though no controlled clinical trials have been run to demonstrate that that is so, I think has the potential of depressing the public's confidence in FDA writ large. This is obviously a matter of significant public concern right now. You hear people who are refusing to get one of the COVID-19 vaccines because they believe that FDA has somehow botched the job by rushing it or by authorizing it as opposed to approving it. A criticism I've always found to be funny, because I did not realize that so many members of the lay public were experts in 21 USC section 360 BBB3. I mean, it's just kind of astonishing, but okay, fine, right? And so I think that FDA should really go out of its way to police attempts to circumvent the therapeutic process, because it really has some significant public health concerns, not just to the use of the product, right, but to people kind of losing their faith in FDA and its ability to keep safe and effective products on the market and unsafe and ineffective products off of the market. We have written about this in the context of attempts to create essentially a DIY COVID vaccine. This is being conducted by RADVAC at Harvard, so kind of no better place to come and bite the hand that feeds you, right, than here. The other flip side, which I think is just garden variety FDA policy stuff, is that we also want to make sure that to the extent these are actually going to be used therapeutically, right, that people are using them because even though it's self-experimentation, they think it's going to treat a particular condition that they have, that there's at least some messaging about some limits regarding whether these things are safe and efficacious. Weirdly enough, FDA has done this pretty well, I think, in at least one instance, and not in others. The way it's done it well in the one instance is this suite of people taking ivermectin to treat COVID. If you go online to FDA's website, FDA does, I think, a good job carefully explaining in simple terms what the problem is about taking veterinary available ivermectin for COVID. You may not agree with it, right? That's a political persuasion issue, but at least FDA has done a good job of saying this is why you should not do that. When it has come to other DIY treatments, FDA has remained mum, and I think they've remained mum because they don't want to make a claim that they otherwise have jurisdictional authority over something when their office of chief counsel has not yet made that determination or not. And I think it's just time. Like this is happening again. We have at least 30,000 people in the US doing it. I have to imagine that during the pandemic, the number has gone up rather than gone down. And so I think it's just time for FDA to kind of draw a line in the sand as to what it's going to do. Right?
And to be fair to FDA, it's also the case that they've had other things on their mind in the last 2 years. Almost 2 years at this point.
Yeah, right.
So this one I think is mainly for Natalie, but spills over, I think, to Emily and maybe to Jake. Commercial databases are known to be skewed toward people of European ancestry. My insertion, as opposed to criminal databases, which are skewed against people with European ancestry in some cases, is that a problem for the predictive value of biomarkers and for identification of criminal suspects? And what might be done about it? Natalie.
So it is correct that that consumer genetics platforms appear to be composed disproportionately of individuals of European descent, also disproportionately of Americans in particular. We should be careful here to acknowledge that being of European descent is not the same as being perceived necessarily as white, especially in light of the history of slavery and assimilation efforts regarding Native Americans, there are many individuals who identify as Black and Native Americans who may, in fact, have some European descent in their ancestry. And so it would be a mistake to think that, as I in fact once did, that the silver lining to investigative genetic genealogy is that it will disproportionately or uniformly identify white perpetrators. That is not the case. It is, to date, it is disproportionately individuals who are white. That has to do in part with the fact that many of the crimes for which there are people still pushing strongly for resolution and for this technique to be used happen to be sex crimes involving white victims. And so those more often than not yield white perpetrators as well. But according to geneticists I've spoken with, in fact, the less specific information we may have for say, Black Americans may in fact indicate that they will be more likely to be approached for additional sampling or more likely to fall under police suspicion more often, because the family trees that can be constructed will be less specific in the first instance. So there will just be less known. So that might mean that fewer of those cases will be pursued, or it could mean if they are pursued, a greater sweep of people will come within police investigation or suspicion and the like.
Of course, one way to avoid skewed samples would be an effective universal CODIS marker database. And I'm guessing, Natalie, you're probably not in favor.
So I will acknowledge that there are some benefits to forthrightly adopting a universal genetic database, put everyone's DNA in CODIS. So I think that there are advantages there of transparency, at least. That it's not a de facto DNA database we get as an end run around, statutory limitations on whose DNA should be available for law enforcement use. Instead, we might have a forthright public conversation about the appropriateness of that broad sweep for law enforcement use. I think that kind of proposal would not be very successful in light of what's happened in the states where there have been efforts to broaden the official DNA database for law enforcement use. As I said in my talk, and I note in the chapter in the book, those efforts have been met with outcry and swift failure. And I think that there are serious constitutional concerns about a universal database as well. So although it would be much more transparent, I'm not sure it would be more legally successful.
Well, we need to go on, but I'll just note that the arrestee databases have not been that unsuccessful. The laws mandating collection from people who've been arrested but not convicted seem to be quite common.
Yes, those are common, though I will note that those are individuals who still have a connection to the criminal legal system, which a universal database would not. Now,
I don't want to disproportionately pick on Natalie or send things to Natalie, but the questions are coming in more Natalie focused. However, this is one I bet all three of you have some thoughts on, if not data on. What do we believe other countries, like, for example, randomly chosen China, are doing with collecting resident or citizen genetic information? Anybody want to have a take on that?
There was a recent report in Nature. It was one of the news pieces about essentially genomically surveying the Uyghur population in China. Although for what purposes beyond that, which can be accomplished by other means, which China seems to be doing, is not entirely clear, right? I mean, it seems like other countries don't necessarily have the genomic privacy hangups that at least some of us share here in the United States, some countries in Western Europe notwithstanding, and the GDPR's regulation of that. But I mean, still not entirely clear what the upshot of this or even what the harms are other than the surveillance harm.
If we want to talk about a country other than China, I will note that the UK is in the process of piloting genomic sequencing for newborns. It's something that we touched on earlier. And so that's something that they are building out, and not necessarily for law enforcement use, for clinical use, perhaps research use, but certainly a greater collection of a greater swath of genetic information.
And close to 1% of their population is in the UK Biobank, which
Yeah,
I think is
I
expected
do
to
not
all
know.
be sequenced. Yeah, it's 500,000 people, which is
Yeah.
close to 1% of the population. Okay, we have, I think, a good closing question directed to everybody. As someone whose work focuses on genetics, but not so much on law, do you have recommendations for resources where I can keep up with updates in genetics-related legislation? And here, because Carmel will want me to, I will say, well, there is, of course, the Petrie-Flom blog, which deals with this, but other comments, other suggestions from you guys about what a geneticist might want to look at to find law and genetics related stuff or learn about it.
So two thoughts, right? So first, there's a wonderful news service called Genome Web, which actually, Hank, you got me on now, 10 years ago or so. They really do some excellent reporting over there. There are also the news pieces from, Nature News and Science, and to a lesser extent Cell, that does some reporting as well. And frankly, Bill of Health is great. Get a lot of different commentators from all over the world posting about, topical issues and short bite-sized formats. I mean, that's where I would.
Bill of Health is the Petrie-Flom blog. I think STAT, which is another really good biomedical health service. Most of it is not about genetics or about genetics and law, but some of it is. Any favorite resource, books, references, resources that you would suggest somebody start with, apart, of course, from the books and articles that all of us have written, which obviously is the important first starting point? Suggestions?
I'll put a plug in for the Journal of Law and the Biosciences. I've found that there's a lot of really excellent work published there that touches on genetics and the intersection with the law.
I guess we better accelerate review of that pending submission from you, Emily. As one of the co-editors in chief of that, along with Glenn Cohen and Nita Farahany. Other thoughts?
I just want to co-sign my co-panelists' suggestions. I think that both the Bill of Health blog and the Journal of Law and the Biosciences are excellent resources, and I have found enriching, the law and policy pieces that are in the major scientific journals. They're not always focused on genetics, but when they are, they're very informative.
Yeah, and Jake mentioned Science and Nature, and to a much lesser extent Cell, but JAMA, the Journal of the American Medical Association, the New England Journal of Medicine, and some of the like JAMA Internal Medicine, and there actually turned out to be 156 different, literally, according to Wikipedia, different Nature publications within that umbrella. They often publish some really good stuff. Glenn Cohen, the director of Petrie-Flom, publishes a lot of work in those venues. But I wish I could say, here's a great book that you can read that will tell you everything you need to know about genetics and law. But nothing's coming to my mind along those lines. Anybody?
You could go through Sonia Suter's casebook, but it's really synoptic in scope. And one of the problems in this area is that stuff moves so rapidly that as soon as something gets into print, literal print, as opposed to the electronic form, there's often something else right around the corner that may otherwise obviate it.
And I have to confess that although casebooks are a less bad art form than law review articles, for somebody who's not in the field, they're not prose that is makes it easy to pick up on things. Even though the casebooks are supposed to be our method of teaching students, they're not all that easily accessible. They're also really, really expensive, and they don't come in electronic versions. buy them used. All right, well, I think it is time for us to end. I want to thank Natalie and Emily and Jake. I want to thank Carmel and all the other people at Petrie-Flom who've put this together. And I want to say, buy the book. What you've just heard is a very small selection from a very rich book. There are 20 chapters. You've heard about 3 of them. There are section intros from the co-editors. It's at Cambridge University Press. It's from Cambridge University Press. You can buy it on the Petrie-Flom website or in, bookstores and newsstands all over the world, as long as they're called Amazon. It's available in hardback, expensive, paperback, less expensive, not yet on Kindle, not on audio yet, but it's such a good book that I would actually volunteer to narrate it. So I looked on Amazon. You can get it as early as this Thursday, but wait, there's more. If you order now, we'll include a free set of Ginsu knives. Not really. Thank you so much for attending. We hope you've enjoyed and appreciated it, and keep your eye open for future Petrie-Flom events. That's all, folks.